Okay, today we're going to be talking about the recall that's now known on the Tundra. We're going to be getting specific. In other words, we all know that Toyota left trash in the Tundra engine, the Twin Turbo V6. What is Toyota saying? What actually happened? Meaning, what technically happened? According to Toyota, they left trash in the engine, and the trash from machining specifically got down here inside of the main journal bearing. So on the main crankshaft, essentially machining trash was left in. It got in the oil here, and then it fused down here to the bearing and caused an issue. So we're going to go over the specifics here according to Toyota. A lot of people are confused. Well, how does trash in the engine screw up the main crank bearing? How does that actually happen? So the first thing to realize is that the materials inside of your engine are kind of like this Play-Doh here. So you can imagine if you had a couple balls or clumps of Play-Doh like this. We have three separate balls here, but if you squeeze them in your hand and apply enough pressure, you can turn all three of these, this red, green, and blue, into one ball. And the materials in your engine are no different. The cast aluminum is soft like Play-Doh, and the bearing material inside your main bearings is also soft like Play-Doh. And as with Play-Doh, if you pressurize the two materials, in this case we're talking bits of metal, if they're under enough pressure, they will fuse into one. They will essentially weld together. And that's exactly what Toyota is saying happened. So imagine there's little bits of trash here inside of this bearing. So this red dot here is going to represent Toyota's machining trash that they left inside the engine. So let's put a piece of trash like right here. Okay, you got a piece of trash right there. Okay, so here's your engine trash here. The thing is, the oil, of course, is under pressure. So remember, oil does not compress. So the forces on your crankshaft, in this case the journal, are essentially transferred from the journal through the oil to the bearing. So the only factor here, once we take away friction, is pressure. So these bearings have to handle the pressure, and they're under tremendous PSI, tens of thousands of PSI. And my point of this rambling is this environment is under a lot of pressure. So just like the Play-Doh analogy, you got these little bits of trash in here, but they're under pressure, tremendous pressure. And what happens is this trash, pressurized, will find its way, as you see here. I'm drawing on the wall of the bearing, or the bearing surface. And essentially, as you can see here, it will essentially fuse itself or weld itself and become one with the wall of the bearing. And this is exactly what Toyota is claiming. Again, I'm not theorizing here. I'm just telling you and explaining you what Toyota has officially said. And people are having trouble visualizing it. This is what they're saying happened. Trash has bonded to the wall of the main bearing, and that happens, as I'm explaining with this Play-Doh analogy. The pressure essentially fuses these things together, and as you can see here, we have a restriction, and a pretty good restriction. Now if we zoom in here, you also notice that we have a restriction that induces essentially a Venturi effect, and that's also probably causing some issues as well. So here we see a diagram of the Venturi effect. And as you can see, if there's a restriction here, so this is your oil flowing within that bearing, but if you have a narrowed section here, the oil is going to speed up. So the velocity or speed of the oil is going to speed up in that restriction. And you can also see that the pressure is going to drop. So if the oil pressure is normal before that mess, that crap in the bearing, at the restriction point, the oil pressure is going to drop, and you could already imagine that low oil pressure anywhere in your engine is not good, let alone at your main bearing. So in addition to having crap fused to the wall of the bearing, which shouldn't be there, you're also going to have this weird Venturi effect, and you're going to have an area of low oil pressure down here. And low oil pressure, again, is not good. Oil won't compress. As we know, liquids won't compress, but oil in a system like this can be displaced. And you can imagine that this area of less and lower oil pressure and lower oil flow is going to displace itself quicker. And that's going to cause the friction and wear, and that's pretty much what happened, and that's what Toyota is claiming. This caused metal on metal contact, and it caused the bearing then to fail. Now, a lot of people don't like that answer. That's Toyota's official excuse. Trash in the bearings, screwed up, and the trash fused the bearing, and it screwed it up. Here's the crankshaft here. It usually happens, I believe, on this either the front one or the rearward one. I forget which one, but that's where the problem happens, and that's Toyota's official excuse. People don't like that, and they want to claim that Toyota's hiding something, and again, nobody has proof either way. We don't have proof that there's any other cause of this, but one common theory, or at least recent theory, is that the crankshaft design here, here's the crankshaft here, and the basically the crankshaft main bearing cap design is the culprit here. So this piece down here is this new one-piece design. The thing is, this is not a new design. This is a crankshaft bed plate. They've been around forever. Toyota has had these crankshaft bed plates on their cars since the 1990s. This is not new. This is not novel. This is not new to Toyota. Excuse me. So this is a theory, but it's unlikely. This is not novel. These things are on all sorts of cars and vehicles since forever. So this is Toyota's 1ZZFE engine. This is your classic Toyota Corolla million gazillion mile engine. And here's the crankshaft bed. This sucker is from the 90s. It's been around forever. And as you can see here, this crankshaft bed is not new. It's tried and true. It's meant to give more rigidity to the engine versus having normal main bearing caps. These kind of cross-sectional webs kind of stiffens up the whole entire assembly. It stiffens up the engine, blah, blah, blah. My point of this rambling is it's not new. This is an old engine. It's been around forever. Crankshaft beds are pretty much on every manufacturer. I'm talking domestic, American cars, European cars. Here's one on who knows what. This one is from a BMW. They're on motorcycles. There's another one. We could go on and on. This one's another BMW. They're on tons of engines, and again, they've been around for forever, and they're on all types, from boats to motorcycles to industrial. So this is unlikely the culprit. It's unlikely that the design of the Toyota Twin Turbo V6, V6's crankshaft bed plate assembly is the issue here, because this is very, very commonplace. So no matter how many times this is said, this needs to always be said. This Twin Turbo V6 is not a new engine. If you're new to Tundras or you're just into Tundras, you may think it's new, but it's been around since 2017. This engine, in some iteration or the other, has been on the road. You've passed by it day in and day out for the last 8 years. It debuted on the Lexus LS without problem. It debuted in around, 2020, 2021 on the Land Cruiser 300 without major issue. The Tundras are having issues. The Sequoia is not having issues, at least, in the same number as the Tundras. And the Lexus LX600 has a few reported issues, but not as much. But it's not a new engine. It has been around forever. You pass these engines every single day on the road without issue. So we have to kind of take Toyota's word at face value here. I know it's very popular and very easy to get on the fear train and say, well, there's an engineering defect. There's no evidence, anecdotal even evidence. So there's not even anecdotes of an engineering error. Nobody can point and say, well, see there, that's why the engines are failing. There's no proof. Not even proof, just evidence. So forget about proof, just anecdotes. Nobody can say, well, look at the oil passages, they're smaller, or look at this design, it's flawed. There's nothing to suggest that there's an engineering problem. And it's fine to theorize, but do keep in mind that that's just that. That's theorizing, and a lot of it, unfortunately, is fear-based. But anyway, the engine machining debris basically wasn't cleared. Everybody knows this, but here's what we're going to highlight, what I was showing you with the illustration there. The pressure on the bearings, meaning the pressure, the oil pressure, transfers to the main bearings from the crankshaft journal. It's so much pressure that the machining debris adheres to the bearings. That is what I was explaining. It just fuse welds like Play-Doh, and it makes this lump or wart or pimple or whatever you want to call it onto the bearing surface. And then you continue down the road at higher loads, more pressure, and basically the failure occurs. So I'm trying to just illustrate and help you get a visual representation of what the heck Toyota even means by that, because again, it might be confusing. But this is exactly what Toyota is saying right there. Okay, we got a problem area here because trash is fused. How did the trash fuse? Pressure, like Play-Doh, fuses these soft metals together. It fuses them into one, and there's your issue right there. A lot of people say, well, it has to be engineering, because how could it happen at the Japanese factory and the American factories as well? How could the same problem be happening? Because it's a manufacturing production problem, as Toyota is saying. They have improved the processes that clear the machining debris since the issue. In other words, they fixed the robots doing the machining. So remember, when your Toyota engine is assembled, it is milled, aka machined, by robots. It is then cleared out by robots. These robots are then programmed by computers to carry out their functions. If there's some calibration glitch, if there's some error in the robots, any sort of error in this production or machining or milling process, there will be a problem, and it will be repeated. It will be repeated in Japan, and it will be repeated in America, so long as the glitch in whatever's controlling these robots is still there. Because the people, whether they're in Tahara plant in Japan or Texas or Alabama or whatever the heck they make them in America, they're running the same software that's telling these robots what to do. And if there's a problem with the software, the same exact problem will be precisely repeated or carried over in both countries. That's why you see the same bearing failure in the same way, because these robots are precise. And that's good when they're working correctly, but it's bad when there's a problem, because you're going to get the same precise error. So the fact that the same problem is happening in Japan on the LX600 and here in America on the Tundra is more proof, or more evidence, I should say, that it is indeed a production or assembly error with these robots. It's more proof to that, because it's happening on both continents here. And you can't say it's one factor or the other. It's the robots are... Anyway, I'm babbling. You get what I'm saying. It's the same thing. By the way, I know you guys all want this. Why can't the Tundra engine be a V? What the heck is this? 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Why can't we get a naturally aspirated V16 engine like this here? Okay, I'll play. Yeah, I know you want a V16 in your new Tundra, but you're not getting it because the gas mileage would be 1 mile per gallon, and even if carb wasn't a thing, you just complain, you wouldn't buy, blah, blah, blah. And that's why you're getting your V6 Twin Turbo V6, because it gives you all the power, more power than a V8, and you're going to love it. Anyway, I'm rambling. That was a little bit of a tangent. Let's get back on track here. These robots here, I know, with this V16 engine, this is the same way your Tundra engine is assembled. If there's a glitch here, you're going to get it on both coasts, and that's how these glitches happen, and this is what Toyota is claiming that they fixed. So this channel is neither a fear-based channel of, oh, Toyota's losing their reliability, the sky is falling, blah, 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 nor is it a shill channel. Hey guys, welcome back to shit. Oh, this is awesome, blah, blah, blah. None of these are my cars, but I'm going to pretend I am. I'm a shill. I'm a sock puppet. That's not that either. We're right here in the middle in reality. And the reality is this. Toyota has nothing to gain by screwing Tundra customers over. Tundra's not popular, but this engine is on all their TNGAF platforms, all their trucks and SUVs. And as mentioned, it debuted in their flagship Lexus LS600. They are very proud of this engine. Lexus is not going to drop that Twin Turbo V6 into their flagship just to screw over Lexus customers and have it blow up and break. They put a lot of R&D. This thing came out. It hit the lot in 2017. This thing, you've passed by this Twin Turbo V6 countless times in the past 8 years without batting an eye at it. Yes, I know this is not a truck, but these weights are similar, blah, blah, blah. It's been on a Land Cruiser for years now, and there hasn't been a lot of issues. Are there issues? Absolutely. There's a recall, but take it slow. Take it easy and got to slow down the emotions and the fear and realize that there's a lot of R&D. This Twin Turbo V6 that you see in these Tundras, this Twin Turbo V6 has sat on a dyno for millions and zillions and trillions of miles. It has been dynoed and dynoed and dynoed at Toyota R&D over 8 years ago. They had at least 3 years of R&D. That puts it around 2015 when they were torture testing and dynoing this thing to death. It is in Toyota's two proud flagships, the Lexus LS600 and the real Land Cruiser, the Toyota Land Cruiser 300 in the world market. This is Toyota and Lexus's pride and joy. Make no mistake about it. They've dynoed this thing. It's worked. So a production error is highly probable to be the actual cause of Toyota Tundra engines blowing up recently. And the fix from Toyota should be a proper full-on engine replacement to Toyota Tundra customers affected by this. I do believe come late June and into July, that's exactly what Toyota and Lexus is going to offer customers, a full-on engine replacement. It costs Toyota nothing to replace this. Somebody asked, can Toyota afford to drop in new engines to Tundra and LX600 customers to make them happy? The answer is yes. This is not their bread and butter at all by any stretch of the imagination. The bread and butter for Toyota is their Toyota hybrid synergy drives, which are in everything from their little tiny Yaris to their Corollas to their Camrys to their Siennas and everything in between, including Lexus. That's Toyota's bread and butter. Okay, they make all their profit margin off of that. So it's nothing to them to offer customers a brand new Twin Turbo V6 that's going to last them forever. I know it's a big purchase to customers, but to Toyota, it's a drop in the bucket. Toyota reliability has not gone south. It's not gone. I know that's a tough pill to swallow right now, but people forget that the bulletproof 4.6 V8 that's in the GX and the Land Cruiser Prado and the 5.7 V8 that's in the outgoing Tundra, they all had engine problems. They all were recalled back in the day. Social media today is spreading this like wildfire, and Toyota needs to act to counter that wildfire. But Toyota's not new to turbos. This has to be said for the zillionth time. They've been making turbo engines in the world market for over 40 years. Turbo engines all over the world market, including trucks like the Land Cruiser. This is a twin turbo V8, not a twin turbo V6. This is a Toyota twin turbo V8. They're not new to turbos. 40 years of turbine engines. Toyota being new to turbos is only what Americans think. They've been doing turbos forever and ever. And someone's going to say, well, this is a turbo diesel. They run cooler, blah, 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 blah. None of that matters. They have gasoline turbo engines in the world market that have lasted forever. So what's going on with the Tundra? Is the sky falling? I miss my 5.7. You wouldn't have missed it when it first came out in 2010 because it was recalled too. How soon we forget. But there was no social media and all this YouTube and Reddit and, social media junk to amplify it at lightning pace. The same thing happened to this 5.7 that this individual misses. It all happened. This happens. It's not problems that Toyota needs to worry about. It's how they solve those problems. And Toyota has a track record, a very good track record, of solving problems. The 5.7 had problems. The 4.6 had problems. But everybody forgets and everybody calls them bulletproof. There's no evidence to suggest that Toyota is abandoning their twin turbo V6 engine that they are so proud of. There's zero evidence that they're just out to screw you and it's all over and Toyota is now Chrysler. Feels weird even saying that. But no amount of logic can defeat fear. So don't let fear consume you. These engines are machined by robots programmed by a computer programmer to do something. And if it's off in a particular batch of engine blocks, a bunch of stuff gets fouled up no matter what country the thing is being made in because the program is off. So that's what you're seeing. And I know it's hard for owners to swallow all this and come to grips because emotions are involved, and that's understandable. Which is why Toyota really, really needs to get on the ball here and realize that they're not in 2010 anymore. That the recall parameters, in other words, when you get a recall back then, everything rolls out in slow motion because that's the way it worked then, and that's the way Toyota thinks it can work now. But they need to update their PR, their customer relations, their public relations. They need to bring it into 2024 and realize that this stuff gets out quick, and so an apology is needed quick and corrective action is needed quick in order to save the reputation of the vehicle, the Tundra to begin with, and then the brand secondary, because these Tundra engines, even though they represent a small portion of Toyota's global sales or worldwide sales, it's still hurting the reputation overall. So they need to get, I'm rambling. They need to get with 2024 and start communicating and saying, hey, we know what's up. Don't worry. The robot's screwed up, and we assure you it's going to be fine, and here's your new engine, blah, 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 and a couple bonus bucks to make you feel happy. But again, I think Toyota is going to make customers happy when they finally come up with an official solution, which again should be coming in the next few weeks. This is just speculation, but Toyota is smart, and he knows that in order to keep customers happy, he's got to do something very exceptional here, and I think customers will be pleased. Until then, try not to worry, try not to be fear-based, and try to understand what happened. Most mechanics know about Occam's razor, and that is the philosophical theory that the smallest culprit, the least likely, or the smallest culprit is the likely culprit. In other words, don't blow something up out of proportion. Don't make a mountain out of a molehill. The smallest, most likely culprit is generally the culprit. Let me get the actual thing for you. Here we go. And this is what I want you to ponder. Occam's razor, okay? We got complex over here, and we got simple over here. And this is what's going on with the Toyota. Toyota, the sky's falling. Toyota's going out of business. Toyota's not what they used to be. This is all this combat. It's an engine design. It's this problem with the too much pressure under the oil turbines and blah, blah, blah. And then too much blah, 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 blah. That's what this box is over here. Okay, that's the imagination. That's the fear in people. That's the fear in the masses. This is the logical side of the mind. This is the fear side. This is the logical mind. Remember, your brain has two halves to it. One is fear and emotion. One is logic and reason. And Occam's razor is used by lots of problem solvers, but actually people use it in mechanics too. So in identifying a problem, what could it be? What is the problem? Start with the simplest. That's most likely the answer. Toyota is having a production hiccup. One of their robots went rogue. There was a software bug in the machining robot. That is the likely problem. Okay, that's what you got to stick. Not all over here. Oh my goodness, what's Toyota does is all that. Then they're gonna fail. Then blah 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 blah. Call the police. I've rambled enough.